Some other topologies might be or can be the WAN, the wide area network topology. Mainly it can be one of three types, depends on the connection that you would like to connect your router to another router, your network actually to another network through the WAN. So you are being connected to another device through ton of devices in the way that you do not own, you do not know, you have no idea about their connection type, vendor, distances, number, etc. But the only thing that you want is that in the end, through the internet, your devices, perhaps both of them are yours, like branch A and branch B, both of them should be connected directly. The first connection can be called the point-to-point P2p connection, and this requires some extra overlay connection to be established and designed in your environment. So you will connect, like, let's say a physical cable to the first service provider that is facing you, and you have no idea about how many connections in there, a battle with some swords, soldiers, etc. So many hundreds of devices in the way, reaching to the other service provider that is connected to the other branch. In the end, what will be happened called logically point-to-point. So your router will logically thinks that there is a really direct long cable connecting it to the other end, and that is the point-to-point. Yes, approachable, applicable, can be done by using some overlay connections that can be discussed in the CCNP in core course, CCNP in NARCI course, CCNP service provider. So both of the CCNP enterprise and CCNP service provider do focus about the point-to-point overlay connection over the WAN topologies. The second type is called the broadcast, also known as the Metro Ethernet or Metro WE, where you have your devices, let's say, that might be connected, all of them to a switched environment. Here there are some switches and there are some layer 2 connection connecting your devices, and they are going to the WAN as well. So sometimes you have to pass from multiple sources to switch or switched environment to reach to the next destination. Well, the question will be, like, are you referring to like it's a disadvantage or something? Well, in module 2, or I'm sorry, in chapter 2, we will talk a lot about switched environment, switched networking, and what is the broadcast actually, because at that time you'll discover so many problems there, and that will be really annoying. Broadcast multi-access, so many issues might be there, but Metro we can solve it, and these technologies are not for here, for CCI, for CCNP DC, CCNP data center, and CCNP service provider. Actually, these are just examples, so that when you are certified and you hear a word like Metro we, broadcast, point-to-point, you don't say huh, because that would be a shame to say really for these fundamentals. That's why Cisco mentioned those. C, the last one for the WAN, will be the NBMA, the non-broadcast multi-access. Well, in that case, you will have, let's say, two connection, perhaps over a broadcast underlay, like a broadcast network, but they will become a non-broadcast multi-access. How? By achieving some extra topologies, some extra overlay to be applied on the topology, so that in the end your communication will not be considered as broadcast. Well, why you keep talking like it's a disadvantage when you mention broadcast? Yes, I will tell you in chapter 2, but until then, a broadcast behavior is very messy. It's very annoying. Sometimes it's called the broadcast storm because it will initiate a storm. Actually, it will destroy the devices. Some other times the broadcast behavior actually is receiving an information from one port, from one source, and automatically replicate and forward the same info to all the other destinations, whether they care or not. So like a switch that have 24 port receives an information, a broadcast info on one port, and the connection is broadcast type. The switch will re-forward the same data for the other 23 ports at the same time. So just calm down, because of these 23 ports, 10 of them perhaps do not care about that. You will exhaust their resources to try to resolve and process these info. Broadcasts always behave in that way, unfortunately. Another type is called the SOHO, the small office, and the home office. These actually are two types, but since each one of them is simple, light, and does not have that much of characteristics, then each one of them, then both of them can be mentioned together. Two terms, yet they reflect two different types of networks. Like for the home office, funny thing is that really like a coincidence that we are talking about such type of top networking after 2019, like in 2020 or 2021. At that time, how much of engineers? 99%, 100% of IT or network engineers do know what a home network is. Working from home, working remotely, where you will connect your computer to the home router. But actually, to be honest, what will be happen is that through the VPN connection, the virtual private network, your computer will not be connected really to the VPN, sorry, to the home router, but it will start from the home router, and through the VPN tunnel, you will be connected to the real router that is in the data center of your network, and thus you will be like participating virtually in the same environment of your network, of your company, and you will be able to start working just like you are at the company, not at home. So that will be the home router. What you would need to do that, you will need a router on your side from home. One single router should be enough. If you would add a switch, no problem, and that should be good. Yes, that should be lovely. Why not? So that will be for the home home office. Yeah, the working from home. For the small office, no, this one is a real office, like having multiple employees. At that case, 3 employees can all be connected to a single switch. That single switch can be connected to a single router. Why a router? Well, later we will study some functions in chapter 4 called like DHCP, NTP, NAT, SNMP, and let's say syslog as well. All of these can be approached by using the home router, can be done. Most of them perhaps by the home router, let's say DHCP, NTP, NAT by the home router, and all of them can be achieved by a home router or a single Cisco router, all of them by a single Cisco router. So that will be enough to achieve all of these, because a layer 2 switch cannot. So all of the employees will be connected together via the switch, and they will be receiving DHCP, NTP, NAT, SNMP, and syslog. All of them will have talking and labs in module 4, in chapter 4, don't worry, and through that router they will go to the cloud. So that will be called the small office, this one. So few users, single router, single switch can be enough. Less concern about, well, less concerned about security, because you can enable some security features here or here, done. Some encryption we'll talk about in CCNP, done. Yeah, very simple, can be in that way, why not? So this will really be less headache when you talk about these environments, when you like to install them, talk about them, etc. The last topic that we need to talk about regarding network topologies will be called what is the on-premise versus what is the cloud-based networks. Well, classics go back 10, 20, 30 years ago, when we talk about you and I are colleagues, and we are working in a network, an environment, in some company somewhere. And the goal or the task or the situation that we are living right now is construct a network, start to build, design, operate, and work, like, yeah, operate a network. Okay, so you start thinking we need servers, switches, layer 2 switches, a multi-layer switch, also known as layer 3 switch, routers, of course, depends on the type, maybe firewalls, yes. In chapter 4 you will learn IP services, so perhaps we would need a DHCP server. These things that I just mentioned a minute ago was a DHCP server, an SNMP server, a syslog server, NAT server, NTP server. Later you will hear about AAA server, and so on and so forth. So many servers, so server, etc. Some routers, switches, different types of switches, and continuously. And if you remember virtual machines, everything, all of these, when you think about them, we think about crates, boxes, purchasing, cables, management. Things are going messy, a lot of things. Okay, so far we are good. That was 20, 30, 40 years ago, perhaps, depends on the time that you're seeing the video. Then you'll have to import them, purchase them, import them, unbox all of them, start building a room that should be the data center, start building the cooling system, the air intake and the air dissipation, or the the drainage of the hot air, system, a cabling tray or cabling system like attached to the ceiling, and another one underlay where we will use something called the elevated floor. Like all the power cables can be under the floor, but you cannot see them unless you remove those removable tiles, and thus it's called the elevated floor. Firefighting system, 1, 2, 3 generators, like 1, 2, 3 redundant generators, not one generator, no, a minimum of 2 generators or more for electricity, and the UPS devices, those electric converters, etc. And security, like securing the racks that I'll talk about in chapter 5 by giving them good doors, unbreakable or good quality doors. Securing your routers themselves by securing their ports and locking them with passwords. Securing the room itself with the smart key, with the card, smart card, whatever, or like the iris scanner or fingerprint scanner, the biometrics. All of that headache and design will take weeks or months. In the end, you will start establishing your real high quality, let's say ISO certified room, etc. And that will be for the sake of having an on-premise network. Yes, so that is the on-premise network. Everything is in front of you in the office or in your company, in the data center of the company, in the server room of the company, in the server farm, etc. So all of that is called the on-premise. Later, something came called the cloud-based networks. So companies like Amazon Web Services, Microsoft Azure or Azure, Google Cloud Services. Yeah, some companies came in to say, hi, I offer you, or we offer you, a data center with all of these guarantees, 100 guarantee and promises in the contract, and you will give us good amount of money and like an annual subscription, and that's it. So again, I will care of almost nothing, only like 10% of the headache compared to days before, because there is a company that will establish for me, will rent or will rent for me a complete data center room in another country. Yes, in that way. It will be done in that way. So I will have a data center, I don't know where, perhaps in Europe, in Poland, and let's say, or Holland, Netherlands, and there I have my room that has 20 server and has 8 routers and 40 switch, and have all of these servers that I told you, and have some management and reporting tools installed, and all of them have public IP addresses or perhaps private IP addresses. What is that? Well, IP addresses will be talked about in a couple of videos coming, but I will be able to reach them through the internet. What I will have in my in my office or in my bank, if I'm working in a bank, or in my enterprise or campus network, I will have my computers, of course, employees are working there. Number one, I will have a couple of switches and a couple of routers, and that's it. That these switches and routers will connect my employees to my remote cloud-based data center, like hundreds of kilometers away from me, and that's it. Differences will be, I will not care about anything regarding that data center. I'll only care that it works 24/7. As simple as that. This is the difference between cloud-based and on-premise. And of course, they will give you so many promises: heat, dissipation, cooling, moisture content, electricity, availability. They will pay that much of penalties if something happened to your rent environment, etc. So that will be the classic will be the on-premise. The other one will be the cloud-based, and the cloud-based, everything is at the cloud company. There will be no headache to care about. That should be the end of this video. That should be enough, because we will talk about other things in the upcoming one. I hope that you will summarize and review everything before you start the upcoming one. I hope that everything is clear for you, and I really hope to see you in the upcoming video. Thank you.